Another example, example 2. And it says an aeroplane takes off from an airport X at an average speed of 650 km per hour on a bearing of 045 degrees for 3 hours. Now the way we draw our diagram, we need to follow what the question is talking about. The first example we solved, we considered two ships that left the port at the same time and they went on different directions. But here we are talking about just an aeroplane. So after flying for a particular time at a particular speed and on a particular bearing and getting to a destination which is airport X, the airplane now changes course again and flies towards another direction at a different speed, and we have another time. So this is a little bit different from the first example. Here we have two values of speed, we have two times. We have the 3 hours is T1 and 2.5 hours is T2. But the first example, we are only given 2 hours, which is just the only time that we are given in the question. So from here we have S1 is 650 km per hour. We have T1, that is 3 hours. We have also S2 is 470 km per hour. And we have T2 to be 2.5 hours. So what we do here is to get D1 and we get D2. And we know that speed S1 is equal to distance 1 over time 1. And the first speed is 650. We are looking for D1 and we are given T1 as 3. So by cross multiplying, we have D1 to be 3 multiplied by 650. And D1 from here is 1,950 kilometers. So also for the second one, we have S2 is D2 divided by T2. And S2 is 470 is equal to D2 divided by this 2.5 hours is the same thing as 2.5. So I write that as 2.5. And cross multiplying here, we have D2 to be 2.5 multiplied by 470. Then D2 will be 1175 kilometers. Now from the values of the speed that we are given for the two airports and for the time that we are given as well, we've generated the distance D1, and this is distance D2. So after getting the values of the two, the next thing to do is to draw a diagram to show the movement of that particular aeroplane that they are talking about in the question. So for the diagram, taking off from airport X, we have this. This is airport X on a bearing of 045 degree. So this is 1950 kilometers, and this is 045 degree. Now getting to a particular point, so we can represent this point with any alphabet. We can use P, we can use K. Let me use K for that. So after getting to K, the airplane now it changes its course and moves towards the east. From 4 cardinal points, this is north, south, west, east. It moves towards this direction to airport Y. Then we join the two. This is 1175 kilometers. The first question is asking us for the distance from airport X to airport Y, that is the value of this line. And to know the rule we are going to use, we need to use what the information we have for this bearing and that movement towards the east direction. We need to use the two to generate an angle here, and that angle from Z angle, when we have this, when we have an angle like this, we call it alternate angles. And there is a theorem that says alternate angles are equal. So if you relate this one that we have like this, as this place is 45, this one is west, this one is south. So I have from there, I have SOX from here. S, that is XOX. This angle A is equal to 45 degrees. That is alternate angles. So this place is 45. And if you look at this one, SOY from there, SOY, this is a right angle. That is 90 degrees. So this is 90. And the whole angle A, we have angle K from there to be 45 degrees plus 90 degrees. And that is 135 degrees. So the angle A is 135 degrees. So the side facing the angles, we use small letters to represent them. So this one will be small k, this one will be small x, while this one will be small y. So for the question that is asking us for the distance between airport x and y, we have to find k. So after getting k, they will now conclude that therefore the two airports, they are a particular distance apart. So that will be obtained after doing the calculation. And from here, if you look at the diagram, we are given these two sides, and the angle that we have, which is 135, we don't know what this angle is. It can never be 45. And the reason for that is this. This is 45. The remaining one is supposed to be 45. But if you look at that diagram, there is another angle A. But the sum of this angle to this place, everything is 45. But we don't know what this one is. It's only after knowing this, or after knowing this angle A, that we can know the remaining angle that we have here. So this is the only angle we know. We don't even know this one too. This is the only angle we know. And from here, we have two sides and the angle between them. So the suitable rule to use there is cosine rule. So from here, by using cosine rule, we need to always state the rule we are using. It is very important. So by using cosine rule, we have the one we are looking for is k. So the rule will be stated in terms of k, y, and x. So we have k squared, which is the one we are looking for, is equal to x squared plus y squared minus 2xy, then cos k. So we know what x is. So we have k squared to be 1175 squared plus 1950 squared minus 2 into 1175 multiplied by 1950, then cos 135 degrees. So we have k squared. The square of 1175, that is 1380625, plus the square of 1950, that is 3802500, minus 2 into the product of 1175 and 1950 is 2291250. And if you look at this cos 135, 135 is more than 90, but it is less than 180 degrees. So obviously this one is coming from second quadrant. And if you look at our quadrant, from first quadrant, all are positive. So sine is positive, cosine is positive, tangent is positive. For this second quadrant, is only sine. We have students. Only sine is positive. So which means cosine is negative, then tangent is also negative. So for us to be able to use four-figure table, what we do here is, since this is coming from second quadrant and cosine from second quadrant is carrying negative sign, then we remove this one from 180, because the maximum angle we have from the four-figure table is 89 degrees. So into minus cos 180 degree minus 135 degree. So we have k squared. By adding these two, we have 5183,125 minus 4582 500 into minus cos 45 degree. So we have k squared to be 5183 183,125 minus 4, 582,500. If you check this one from our four-figure table, we have minus 0.7071. So from here, since this minus 4,582,500 is affecting minus 0.7071, so we go back to this. Minus multiplied by minus. So the sign will change to plus. Then we have our k squared to be 5,183,125 plus the product of that one will give us 3,240, then 285.75. And if you add the two, we have k squared to be 8,423, then we have 410.75. And we have an expression that is talking about square root, that's talking about square a. So we take square root of both sides. So by doing that, we have k squared is equal to square root of 8,423,410.75. So square will cancel square root. Then k from there will be 2902.31 kilometers. But the instruction we have in the question says we should do our answer to 3SF. And to 3SF, that is significant figures. The position of a number will determine if the number is significant or not. From here, our first significant figure is 2. So from there, k is equal to, that is 2. The second SF is 9. The third SF is 0. Now what we need to do is to look at the next one. The next number is 2. And for numbers between 0 and 4, they will be rounded down to 0. But for numbers from 5 to 9, they will be rounded up to 1. Because this one is 2 and it is less than 5, so it will be rounded down to 0. Our answer, when we are doing approximation, our answer must be of the same magnitude. That is, I'm talking about our approximated answer. It must be of the same magnitude with the answer that we have obtained from our calculator. As we have 2902 here, I've seen students at times when they are approximating, they write the answer as 29. And they will conclude that that is the answer. That would be wrong. If a student should do that, then some students will not earn all the full marks that he or she is entitled to, because the answers are not of the same order of magnitude. So at times, if you have two digits like this, and we want our answer to be of the same order of magnitude, what we do is we paddle the result with 0. So this will be 0, 0, and that will be kilometers. And the reason for this answer is from the question 3SF. And that's the answer. K is the distance between the two ships. So therefore, we can just conclude that therefore the airport are 2,900 kilometers apart. 2,900 kilometers apart. So if you have been following me, you notice that in the previous examples that I solved, I used A, B, and P. And this one, I'm using X, K, and Y. These are just alphabets. Normally, what cosine rule says is we have A square is equal to B square plus C square minus 2BC cos A. So the first thing we have here is the one that is the unknown that we need to find. So the other ones, they are the given ones, that the unknowns that we already know, that we are given in the question. So this value of cos A is from the angle of A. And that means what? We are given angle A and two sides that are with A. Or we can put it as we are given two sides and this angle A that is between them. So we can twist this one anytime. This alphabet ABC at times can be replaced with X, Y, and Z. At times it can be replaced with K, L, M. At times it can be replaced with C, D, E, any three alphabets. Or even as we have this one, we have X, K, and Y. Since K is the one we are looking for, that's why we are having K first. and the angle we know here, or the angle we have calculated here, is angle K. That's why we have this big K. Don't forget that capital letters are used to represent the angles, and the side facing the angles are represented with the small letter. So that's why we have this, because we are looking for K. We have K squared being stated with the other ones that we are given, x squared plus y squared minus 2xy then cos K. Assuming this one is A and this one is B, this will be stated as K squared is equal to A squared plus B squared minus 2AB cos K. Or assuming these two, if this one is M and this one is N, this will be stated as K squared is equal to M squared plus N squared minus 2mn cos K. And if that angle is not K, if it is Y or if it is P, that will be stated as P squared is equal to, if this is not K and it is P and this one still remain X and Y, we have it as P squared is equal to X squared plus Y squared minus 2xy cos P. So the one we have here will be the value of our cosine. If this one is M, this one will be cos M. This one will be small m and this one will be cos capital M. If this one is N, small n, this one will be cos capital N. And these two, they will be the values of the sides that we already know. So average speed, we are still making reference to the formula I gave earlier, that speed is equal to distance over time. So the difference between speed is equal to distance over time and average speed is, for average speed, we'll be talking about the values of two, distance 1 and distance 2, and different times too. So the formula for average speed is average speed is equal to total distance divided by total time. So from there, the total distance, we add these two values that we have. We add 1175, it will be added to 1950. Then total time, the time for the first one we are given as 3, and the time for the second one we are given as 2.5. So by adding these two, we have 3125 divided by 5.5. So our average speed is 568.182 km per hour. But the instruction from the question is that we should do our answer to 3SF. So our first SF is 5. For any number, the first number that is appearing is the first significant figure. 0 in most cases is less significant. But in some cases it will be significant, but that depends on the position that 0 is occupying in a particular number. Now if you have something like this, if you have 101 and we have 110, the position of 0 here is making it to be significant. So this one, I can say that this is 3SF. But this one, the position of 0 here is making it to be insignificant. So this one is to 2SF. So that is for 0. But for this one, 5 is our first SF. The next one is 6. That's our second SF. And the number that is meant to be our third SF is 8. So what we do there is we look at the number after that third SF. After the degree of accuracy, degree of approximation that they are asking us to do. So after 8, we have 1. So 1 is less than 5, so it will be rounded down to 0. So 8 will still remain 8. That is kilometer per hour. And the instruction is 3SF. That's for the second one. And for the last one, the last question is asking us for the bearing. They are asking us for the bearing of airport Y, of this airport, from airport X. So the bearing the bearing will be traced from X to Y. So we take it from X. That is, what that one is saying is that we have to calculate the angle from this north pole to the line that is connecting X and Y. So this is the line connecting X and Y. So we get this, and we know this one has 45 degrees. So what we need to do here is to get this angle. So the addition of this angle and this 45 degree will give us the bearing of airport Y from airport X. So we should be very careful with that word from. So at times when we have from x and we are taking our from y, then we get a wrong answer. So the suitable route to use here, since this one is, we already have the complete version of this, that is 290, I think 2908 or so. We have 2900, but at times when we are doing our calculation and we need the answer that we have obtained earlier for further calculations, we are not to use the approximated answer. We are to use the exact answer, because if you use approximated answer, there's a particular topic in mathematics that we call error. And even when the examiners, when they are marking an examination, they give room to error, but the error they give room to is very small. Like for this one now, if we are meant to get an answer of maybe 45 degrees, we give room to maybe 43 and to 47. So when a student is now having an answer that is less than 43, then such answer is wrong. When the student is having an answer that is more than 47, then such answer is wrong. And those wrong answers, they will be obtained as a result of carelessness during approximation. So that's why it is advisable that we make use of the exact answer when we want to use the obtained value for further calculation. So from here, we are going to make use of our 2902.31. That's what we make use of there. So this one, K is complete already. And this one that we are looking for, which is angle X, is not complete. We have the side, we don't know the angle. So when we have a complete side and angle, and we are combining with an incomplete one, so that one we are to make use of sine rule. So from there, using sine rule, the one that we have, that is K over sine K. And the one that we are looking for is equal to X over sine X. Our K from there is 2902.31 divided by sine 135 is equal to X is 1175 divided by sine X. And from here, if you cross multiply, we have 2902.31 sine X is equal to 1175 sine 135 degree. And after that, the next thing we do, if you look at what we have here, we are looking for sine X. We need X actually, but we have sine X here, but there is a particular value that is disturbing sine X, which is 2902.31. And what we do here is we divide both sides by that value. So we divide both sides from here by that 2902.31. So this is divided by 2902.31. This is divided by 2902.31. So this will cancel this. So from here, for us to be able to use fourth figure table, we need to express this 135 degree as an angle from the first quadrant. And this 135, as I've said earlier, is from second quadrant. And from second quadrant, it is the only sign that is positive. So this one will still remain positive. The sign will not change. So we have sine X to be 1175 sine 180 degree minus 135 degree divided by 2902.31. So we have sine X to be 1175 sine 45 degree divided by 2902.31. Then we have sine X from there, it will be 1175 multiplied by, if you check sine 45 from our fourth figure table, we have 0.7071 divided by 2902.31. So if you get the product of the numerator, and the product of the numerator will give us 830.843 divided by 2902.31. So sine X from there will be 0.2863. This is sine X, but what we need is the value of X. So what we do here is we check for arc sign of x. We go to our 4-figure table, we open to sign of angles, and we check for the closest value to this, the closest value to 0.2863, and if you do that, we have x to be arc sign of 0.2863, and the value of x from there will be 16.63 degree. That is this angle, 16.63 degree. And from my previous explanation, I said we are to trace the angle from the north pole to the line that is connecting x to y. Therefore, bearing of y from x will be 0.45 degree plus 0.16.63 degree, and that will be 0.61.63 degree. But the instruction from the question is that we are to do our bearing to the nearest degree. So to the nearest degree, this will be 0.6. What we have after 6 is 1, and what we have after 1 is 6. So this 6 will be rounded up to 1. So to become 1, the addition of 1 to 1 will give us 0.62 degree. And that's the answer.